Okay, so now let's take a look at the classwork and let's see how well we did. Sulfuric acid plus 2 moles of potassium hydroxide. So step 1, write the charges. +1, -2. Potassium is +1, hydroxide is -2. Remember, if we look at the periodic table, and I'm going to ask you to take a look at your periodic table, potassium, +1, +1, +1, +1, +1, +1, all losing 1 electron. Metals are on the left, they lose. So it's very, very important that we recognize that these charges tell us the number of electrons lost. And remember, alkali metals, alkaline earth, transition. So, acid plus a base is a salt plus water. So we're going to have a double replacement, and I'm purposely not putting the answers down for myself so I can think through it just like you. I would say, oh, okay, definitely the H is going to go with the OH. So the K is going to go with the SO4. No big deal. The positive always goes first, so I'm going to write the K associates with the SO4. We realize, oh, this is +1, this is -2. You can't have that. You have to balance the chemical formula. But hold on. Plus H will go with OH. Okay. Well, now I have to look and make sure I write the formula correctly. So this is a -2. This is a +1. This metal lost 1. This polyatomic gained 2. So I need a subscript of 2 down there. Potassium sulfate, ionic, covalent inside. So this has both types of bonds. Water, HOH, polar covalent. All right, that looks good. I have my salt and I have my water, but am I balanced? No. Well, let's see. We have 2 Ks here, 2 Ks here, so that's all right. But what's the problem? I have 2 H's here, but I need 2 H's here. So I'm going to put a coefficient of 2 in front. All right, so that helped me out. So here's the 2 H pluses, right? And these are the 2 H's. 2 now distributes to the hydroxide, and then the 2's up there already. So that looks good. We're done. So it's 1 mole of sulfuric acid plus 2 moles of potassium hydroxide, double replace to make potassium sulfate, and 2 moles of water. Now, technically, again, students, this should have AQ, 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 but, you know, this is a double replace. Why is this a neutralization? Because water is formed. Okay, let's go to the next one. Polyatomic. So if this is +1, because hydrogen is written first, can you see that PO4 has to be -3? Has to be. Here's the little subscript of 3 down here. But if you don't remember that, or if you get confused, remember what we've been saying. You have to navigate your reference table. Oh, there it is. PO4 has a -3 charge. Phosphate. Calcium hydroxide has to be -1. Calcium has to be +2. Let's remember. Go back to your periodic table. You can hear me turning the pages, right? Calcium, +2. Has to lose 2. Metals are on the left, they lose. Even my dog knows that. So we have, I'm cracking myself up, students, I'm sorry. This has been insane. All right, so now we have to do the double replace. So we know calcium is the metal that's first and phosphate is second. So Ca goes with the PO4. So that's a +2 and that's a -3. And it is definitely going to be HOH. This is going to be a little hairy to balance, but not really. We know now that we have to write the subscripts of this. So this is a 3 and this is a 2. And HOH is the water formed. So how many, let's see if we can do this by inspection. 3 CAs, 3 CAs. All right, that's nice. 2 PO4s, PO4s, 2 of them. All right, I'm liking it. And then we have 6 H pluses. I don't have any 6s over here. And then 3 times 2 is going to be 6 OH minuses. How are we going to fix this? 2 times 3 is 6. 3 times 2 is 6. Put a 6 right in front. I like it. So 2, 3, 1, 6. Six moles of water yielded. That's the quintessential Regents trap. If you can't balance something 99% of the time, you didn't write the formula correctly. Okay, last one. Nitric acid plus barium hydroxide. Step 1, put in the charges. This is a +1, -1. This is a -1, +2. Barium has no other choice. Okay, double replace. Acid plus the base is a salt plus water. So we have barium going with the nitrate. So Ba +2 and the NO3 -1. All right, so now we know it's just going to go HOH. All right, so we need a subscript of 2 down here, because this has to be +2 and this is -1. Lost 2, each one gained 1. So there's our salt, barium nitrate, and HOH. So here we go. Let's see, do we have to balance? Barium, barium. Oh, 2 OHs over here. And then 2 NO3s over here. All right, I see it. I see it. So if I put a coefficient of 2 here, remember what we always say. What's the consequence of that? So now there's two H pluses. So let me fix that. And then two NO3s. But I like that because it's in the formula. And now, this is great, people. Two hydroxides. Two hydroxides. Hey, that looks good. Okay, so we did it. We were able to do a double replacement, balance the chemical equation, see the formation of water. We made a salt. So it really looks good. This is acid-base neutralization. I think this is as tough as it gets. I believe that there is more practice in the packet. But my hope is if you can do these, following the classwork and the work that we just did together, you should be okay. And we will progress to the next lesson, which is simply going to be an expansion of the Arrhenius theory. Not difficult at all. Okay, so let's stop there now. That ends the classwork and the answer key for acid-base neutralization.